Ancient space dust analysis could solve the mystery of the origins of Earth's water. The origins of Earth's water have always been a mystery for man, and an international team of scientists may have just solved it. The unlikely culprit, based on a very persuasive piece of evidence uncovered by the team, appears to be the Sun itself. This team of researchers from Australia, the UK, and America have recently published a paper in the journal Nature Astronomy describing their research and discovery that water was carried by extraterrestrial dust grains to Earth and bases on the analysis of the ancient asteroid. Charged particles from the Sun itself, known as the solar wind, have altered the chemical composition of the grains, which resulted in water molecules being produced in the grains, which is the process known as space weathering. This is a finding that can be answered to a very long-standing question of exactly where the origins of water on Earth are from. Earth is unusually water-rich, with oceans that are covering up to 70% of the surface, which is significantly larger than any other rocky planet in our solar system. This finding can help future space missions in finding sources of water on worlds that have no air. The C-type asteroids. The source of Earth's oceans has puzzled planetary scientists for over decades. One of the many theories is that a space rock known as a C-type asteroid, which is a water-carrying rock, could be the source that brought water to the planet during the final formation stages 4.6 billion years ago. This theory has been tested by scientists previously by analyzing the isotopic fingerprint on chunks of C-type asteroids which have fallen to the Earth in the form of carbonous chondrite meteorites, which are water-rich. The terrestrial water and the meteorite water were compared by testing the ration of hydrogen and deuterium. If they matched, the conclusion would be drawn by scientists that the C-type meteorites were indeed the likely source of water on Earth. However, the results of this theory were not quite as clear-cut. While some of the deuterium hydrogen fingerprints of the water-rich meteorites were a match with the Earth's water, many of them did not. When the average of all tests was taken, it was observed that these meteorite liquid fingerprints did not line up with the water that can be found in Earth's mantle. It even went on to show that the Earth has a slightly lighter but different isotopic fingerprint. The conclusion that while Earth's water did not contain water from C-type meteorites, there must have been at least one more source of water at the time of Earth's formation, from another isotopically light source coming from anywhere in the solar system. The S-type asteroids. The S-type asteroids is another type of rock that orbits the Sun a bit closer than the C-type asteroid. Samples of these rocks were scrutinized by a team led by the University of Glasgow using atom probe tomography, which is a new cutting-edge analytical process. The analyzed samples were taken from the Japanese space probe Hayabusa, which had returned to Earth back in 2010. The use of this process allowed the team to measure one grain at a time for their atomic structure and also enables them to detect any individual water molecules. The team showed that a significant amount of water was found in the dust-sized grains from Itokawa, just below the surface by space weathering. The early solar system is known to have been a very dusty place. This allowed a significant amount of opportunity water to be produced under the surface of the spaceborne dust particles. Researchers have suggested that this water-rich dust would also have rained down alongside C-type asteroids on the early Earth and resulted in being a part of the Earth's oceans. How the solar winds create water. The lead author of the paper is Dr. Luke Daly from the University of Glasgow School of Geographical and Earth Sciences. The lead author explains how the solar winds are essentially mostly helium and hydrogen ions that constantly radiate from the Sun into space. These hydrogen ions penetrate a few tens of nanometers when they hit an airless surface such as a spaceborne dust particle or an asteroid, resulting in affecting the chemical composition of the rock. The space weathering effect from hydrogen ions over time can lead to ejecting of enough oxygen from different atoms of different materials in the rocks, which will create tapped water or H2O within the minerals of the asteroid. He also elaborated that this water derived by solar wind, which was produced by the Earth's solar system, is isotopically light, and this makes it highly likely that the fine-grained dust that was buffeted by the solar wind and swept towards the forming Earth billions of years ago could be the missing source of the planet's water reserves. How much water is in the space rock? The co-author of the paper, Professor Phil Bland, is a John Curtin Distinguished Professor at the School of Earth and Planetary Sciences at Curtin University. The co-author explained that atom probe tomography allows us to look in detail inside the first 50 nanometers or so of the dust grain surface on Itokawa, which orbits the Sun in 18-month cycles. It's also enabling the researchers to observe that the amount of water in the space-weathered rim was enough to, if scaled up, amount to about 20 liters of every cubic meter of rock. Atom probe tomography. Professor Michelle Thompson is the co-author and also a renowned professor at the Department of Earth, Atmospheric and Planetary Sciences at Purdue University. Professor Thompson acknowledged that this kind of advancement and measurement would have been impossible without the remarkable technology of atom probe tomography. This is the technology that gave the researchers an extraordinary insight into how the tiny dust particles that float around in space also play a role, allowing us to help balance the isotopic composition of the water on Earth while also providing us with clues to help solve the mysteries of its origin. Help from colleagues. It was acknowledged by Dr. Daly that while the probe tomography system at Curtin University was a world-class technology setup, it had never before been used to analyze hydrogen in the way that they were doing. It went on to be explained how it was determined to make sure that the results were accurate. When he presented the preliminary results at the Lunar Planetary Science Conference in 2018, he openly invited any interested colleagues to help validate the findings, and they have joined colleagues in the NASA Johnson Space Center and were offered help from the University of Hawaii, Northern Arizona Universities, and Idaho and Sandia National Laboratories. These people provided samples of similar minerals which were irradiated with deuterium instead of hydrogen, helium, and the results from the atom probe for those materials classified that something highly extraterrestrial was going on. The team highly appreciated the efforts of all colleagues who helped and supported their research by creating a dream team for space weathering. The resulting evidence was very exciting and held the possibility to open the door for a much better understanding of how the oceans of the Earth were formed and what the early solar system looked like. Advances in a decade. Professor John Bradley is a co-author of the paper and the professor at the University of Hawaii at Manoa, Honolulu. According to him, the study proved that the notion of solar wind radiation would have been greeted with skepticism as recently as a decade ago. Their study built on the production of water in situ on the surface of an asteroid and resulted in evidence that the interaction of oxygen-rich dust grains with the solar wind does indeed produce water. Estimations of the amount of water in space-weathered surfaces gives a possible method for future space explorers to manufacture supplies of water on even the most seemingly arid planets. According to Professor Hope Ishii, co-author of the University of Hawaii at Manoa, for any future space exploration, one of the major problems is how the astronauts will find water enough to allow them to stay alive and complete their tasks without carrying it on the entire journey. It's expected that on many other airless worlds like the Moon or the asteroid Vesta, the same space weathering process may have created water in some degree in the same way as it created water on Itokawa. With this discovery, it could be possible for future space explorers to process fresh supplies of water straight from the dust on the surface of the planets. The thought that processes that form the planets themselves could be the means to allow human life to reach out and survive beyond the Earth. Dr. Daly also revealed that NASA's Artemis project is set to establish a permanent base on the Moon, and hence if similar water reservoirs have been sourced by solar winds, then this could become a valuable resource to the team in achieving their goals.